So I take only one attendance, so you can, if you hadn't do, just please do it.
Teacher, I said yes. Can you check if it's okay?
You see, okay. The thing is that right now I cannot check. Later on, I need to go to my Office account, Office 365, and then I will get an Excel file, and then I see your name saying that, like, for example, what was your name? Who told your name? Who asked me that? Mert, you. Uh, so, for example, let's say Mert. When I see the Excel list, I will see name Mert. Mert Deniz Tatlı, say yes, like, let's say 1:10. So I can see from there the time also.
Excuse me?
Yes. Yes, Mert. I was giving example. I was giving example. So I said that. So I did an attendance form. So now you say yes there. Then when you cannot see your name, but when I go to Office program, Office 3, not program, is the platform, Office 365, I will have a Excel list. And in this Excel list, I will see, for example, what I was saying to the students, Mert said yes at that time, for example.
Yes.
Yani this works like that. I'm just telling students how it works.
Okay, I understand.
Yeah, it works like that. And at least it was working like that before. So let me check actually. Let's check. So let's see. Today is, yeah. Oh, actually I should write. Yeah. So let me show you also. Now we are recording, am I right? Yes. Now where is the okay. Now look, can you see my screen?
Yes, we can.
So here I will click this Excel file. It's opening. Now I will click this one. See? Now this gives all the list. So Mert, for example, said yes. 125. Kyra says 124. Ahmet Abush 1236. Kaan Sulkalar 1237. Berat, for example, 118. Can you see? So it comes me right there. Just in case I want to tell you how the system works. So someone asked me, so I don't remember this person. He asked me in the beginning of the class. He said, yes, so my friend, you can see yourself here. I don't remember you, so you can see. If you say yes, so I hope you are here. Anyway, okay? Good. Now we can go back to our lesson. Our wonderful students back to class. 14 students here. Some guys, maybe they have clash. Let me ask them to join also. Now let's go on. In this part of our class, we will enjoy with operations on sets. Okay? Do you remember what kind of operations? We have union. Now, firstly, can you see my screen clearly?
Yes.
Yes, we can.
That's a wonderful news. So I can continue. So we have what? Union operation. This is one kind of operation. Union sets A and B. We write like that. A union B is the set of elements in A or in B or in both. the intersection of A and B written A intersect B is the set of elements which belongs to A, both A and B. So if A is ABC, B is AX, Y, B, then union is all of them, right? Like A, B, C, X, Y. So we don't repeat A's. I told you the reason. You have only one A. So from here you get A, from here you get A, but in the sets we only take one of them. So in the intersection A in both of them, B also, what else? No, so that's it. A union this guy, so this is like a set now. This is empty set, but this comes with as an element of set. So you also now in the union you write this empty, right? And this intersection empty because both of them not have any common element. For any set A is union with empty set is A intersect with union, A intersect with empty set is empty set. We have some, in general, some properties as within addition and multiplication of real numbers, the union and intersection of sets are associative operations. To say that the set union is associative is to say that, so you first do this union operation and you make union with A3. This is equals to you do the operation with A2 and A3 and then you make with this guy. So this should be the same. So it follows that we have this one. You can also write that. The union of n sets, like say A1 to AN, is written like that, but more nicely you can write like that. So this means that I is 1, A1, union with the next I is guy, Y is what? 2, A2, the next I is what? 3, and so on. So instead of writing this, you can write like that. It's more nicely. The intersection of these n guys, you can write like that this time, more nicely. So when I is 1, A1. When I is 2, you have the operation coming up firstly, and then the A2 comes. When I is 3, firstly this intersection comes, and then A3. You know, this works like that. These are just notations. Then we have Venn diagrams. I think most of you remember Venn diagrams, right? I think you know the Venn diagrams. Usually in the Venn diagrams, we have a universal set. We have sets here, A, B, C. My friends, here, for example, so from this book perspective, he was saying that this diagram enables us to see that in general, A intersect with B union C is not equals to A intersect B union with C. So if you want, we can practice and see, yes, this is in general, it's not happening. Can you see that B union C is what? So this guy and this guy, all elements are what? These ones. Are you okay with this? 3, 5, so sorry, 7, you have 2, 3, 5, 4, 6, right? So B union C, this one. Now, A intersect with this one. So A is this one. If we intersect, what guys comes? 2, 3, 4. You are okay with this, right?
Yes.
Maybe 2 is, I don't know, but I need to be sure that, because all students are important for me, and in the exams we ask sometimes, so it's good. Now A intersect B, yes. So A and B. The guys are in A and B in both of them. What are they? 3 and 4. As you see. So what happens now? As you see, this is not holding me. Let's see why. Because now what is this? A intersect with B union C. This is 2, 3, 4. This side is 2, 3, 4. Is this also 2, 3, 4? So 3 4 union C, 3, 4 union C, so at least you will have 7. So this will not equals to this one. Okay? So in general, this is not holding. In general, but we have this. A intersect with B union C is equals to A intersect B union with A intersect C. My friends, I will solve one exam question, but before that, I would like to tell you some more terminology. It's like disjoint sets. Like sets A and B are disjoint if they have no common elements. So A and B, can you see that? They are disjoint because their intersection is empty. So if we have two sets and their intersection is empty, that means they are disjoint set. Do you understand?
Yes, yes. Yes.
Yes. Incomparable sets. So sets A and B are incomparable, if A is not subset of B and B is not subset of A. So yeah, actually logical, isn't it? Because you cannot compare that. If one of them is subset or not, you don't know. Like, because A is not subset of B here, right? And B is not subset of A also, you cannot compare. So that means incomparable. After this nice and also important informations, we can continue with set difference. Set difference of sets A and B written like A/B or like that, A minus B in some books, in YouTube or somewhere you can see like that. You can read this like A without B. This means that A without B is the set of those elements of A which are not in B. The complement of set A is the set A to the power like C. This, like, as a notation, I am saying that you are not taking power. So, or you have C here, so A and C here. So this means that U/A. So U without A, where A is some universal set made clear by context. Sometimes in some books, we have some bar in here. So you have the set and the bar. So that means also the complement. Okay, so there are different notations. Like here, as you see, ABC/AB is what? C. ABC/AX, what? BC. AB, this set, and AB empty and slash empty is what? So this is AB empty. In here, empty is an element. AB empty slash, can you see that now this empty set appears as an element in a set. So for that reason, you have only here AB. We have an example from the daily life. So if A is the set Monday, Tuesday, Wednesday, Thursday, Friday, the context suggests that the universal set is the days of the week. So everything in the set, in the universal set, universal set contains every element. So what are the every elements? Like all the days of the week. So A complement will be Saturday and Sunday, because in the universal set you have the days of the week. So A complement means that U/A. U is that universal set. So you have Saturday and Sunday. You okay with this? Saturday and Sunday?
Yes.
These are holidays, but this is not asking you to find the holidays. This is the example for the complement. Okay, right. We have some properties like this A/B also can be written like A intersect B complement, and also that this is important. The complement of A is A. Okay, like in here there are some examples. Here, for example, you have A. So x is an integer, x squared is bigger than 0. Okay? Then what is the complement of a? 0. Because this is the guy when you take its square, it's not bigger than 0. And it's an integer. Because, okay, I think you are clear with this. You cannot say -5 because if you take its square, it's 25. It's bigger than 0. So this guy is the only guy which is not in here but in the universe. Okay, when you think about these integers. Okay, you remember the integers, right? Integers.
Yes.
Where are the integers? Here. See, like minus guys, 0 and plus guys. So in here, whatever you take from minus guys, if you square, is always bigger than 0. Whatever positive guys you square, bigger than 0. And this is all your universe. And this guy is the only guy that when you take it square is not bigger than 0. It's equal because. So this was the reason. Sorry about this. We need to find now where we were. Oh yeah, we were here. Yeah. See, universe is the Z. All integers. So the complement of A is again A. Right. Oh, we have one exam question in the past years. Again, my friends, did you understand from where you will look at the past year exam questions? Open course. Okay? Open course. From here. Bank. You are going to bank. But what bank? Question bank. So from here you can find. Right, what we were doing. Let's continue. So this is one exam question. This question was asking to students use Venn diagram to show that complement of A union B is equals to A complement intersection with B complement holds for any two sets A and B. My friends, what you are doing, you will use this Venn diagram. So this is your universal set. So what you will do, you will first find this guy using Venn diagram, and then you will construct this one using Venn diagram and see them, they are the same. So you start with the first one. Usually we start from the left. So A and B, like that you have, okay? Now, okay, the operations, firstly you should do union, okay? And then you will look at complement. So in here the union is the yellow part. I think it's clear. Now, what is the complement of this? Just the guys which are on in the universal but not in the union. Complement. Okay, so you have
that it's not in the set, right?
Yes, exactly. Yes, exactly. None the elements which are not in any of A or B. You see this one, right? If I didn't wrongly hear. Can you repeat what you said?
I said it's gonna be anything that is not in the sets.
Yes, exactly. Sets. You said sets. Yes, A and B. You mean? I understand. Yes, exactly. So yellow part. Yes, this part. This. As you see, the yellow part. Your friend is very correct. Now, so left part, we drove the Venn diagram, and see we have this. Now, have a look at right hand side. So right hand side, yeah. So A and B. So A here, B here. Okay, firstly A complement. So the guys which are not in A. So these guys. So these all in So this part of the B and the outside. Now, how about the B complement? Then these guys, the gray, I hope it's gray or gray, how do you say gray? And these parts. Now, if you look at the intersection, so what is the intersection? Intersection of this one and with this one. Of course, these guys again, the elements which are not in any of the sets. So as you see, these gray parts and this yellow part are the same. So we solved the equation. We are okay. You okay with this?
Yes.
There are very similar equations. I advise you to check, and I don't have much time. You can check it from the past year exam questions from again here. You can try the midterms or quiz ones. Okay. So see, for example, these midterm or quiz ones, you can try and see the similar ones. Let me close this one also, this one we don't want. Okay, yeah, my friends, let's see something. Okay, yeah, then yeah, actually this is about the laws of De Morgan. Actually, we just union B, A union B, yes, we just prove this one using the Venn diagrams. Actually, now I will tell you this. Now, interval notation, but firstly, I want to mention, I think at least in calculus 1, you solve these ones. I am predicting. So this is a closed interval. Like in here, you have x guys. Of course, this is in real numbers. A is smaller or equals to x, and x is smaller or equals to b. So a and b is included. So open. That means the x guys are real numbers, but the x guys cannot be equals to a and b. So a is smaller than x is smaller than b. Here, this is half open or half closed. You can think half open, it says here, but you can also think this like closed. But usually half open term is used. So half open means now the x guy can be equals to b, but x guy cannot equals to a. But and then of course, from A to B, you have the elements. Here, this time A is included, B is not included, and the x guys are from A to B again. Okay. There are also others from minus infinity to. These are also important. Let me highlight this one. So highlight the steps. Okay. Now, yeah. Okay, just these are reminder. Now, yeah, here, for example, we have one example. A is minus 4 to 4. Can you see that? B is 0 to 5. Now, what is A slash B? That means A without B. Now, A without B will be what? So the guys will be in A, but not in B. So, like, of course, it starts with minus 4 and it's included. But it will come up to 0 because 0 is in the B. But not included because B starts from here, 0. So from here, it comes, stop here. Doesn't take 0. So this is minus 4. From minus 4 is closed. From 0 is open. This is homework for you. You can check. You okay with this? Pause 5?
Yes, hocam.
Yeah, very good. Right. So next target is symmetric difference. The symmetric difference of two sets A and B is the set. This symbol, so like you have a circle and plus inside. B of elements which are in A or in B, but not in both. Okay, it's quite different than the others. Also, this delta is also used, the notation. Okay, so don't surprise if you see this also in some books. Let me highlight this also. So we have two equality, let's say. So you can find this the symmetric difference of A and B. So like one of them you can use this. So A union B slash A intersect B, or you can use this A slash B union B slash A. So have a look at this. So symmetric difference of A, B, C with X, Y, A. So again, look at it. You can use this. So first you can find what is A union B slash A intersect B, or you can just go through the definition. Doing this is much, I think, much helpful for you, but just looking the definition, or you can also write this directly. What does the definition says? The set of this symmetric difference of A with B, the elements which are in A or in B but not in both. So basically all the elements, but we don't want the intersection ones. So what are the intersection, guys? A. So in here A shouldn't be. What are the intersection, guys? Another intersection do we have? No. Then the rest is here. B, C, X, Y. Can you see that? You just don't take the intersection, then you take the rest. See, I didn't take A, but I take the rest. B, C, X, Y. Or you can do this like that. So if you can first write A union B, if you want, we can do this. But where are we doing this? So you can write comments. You can take your pencil and write your pencil. So what is A union B? So sorry, my handwriting is not good. So A union B is, so I'm saying for that, actually we don't have, so let's say this is A, because you will ask me, oh, what is A, what is B? Of course, this is A and this is B, let's say. So what is A union B? This all right. A,
B, C, X, Y.
A, yes, you are very good. A, B, C, X, Y. Of course, we don't repeat A. Now, A intersect, sorry. You know it is not that easy. You can try yourself also. Not that easy. Okay, and why I write C? We don't have C, but don't worry, we have also eraser. C, we have eraser. So use the eraser. Okay, now, okay, A. So C, now, A union B slash A intersect B. So all these guys except this C, B, C, X, Y. Okay? Yeah, it's like that. So you can do this also for this one and this. So here, this is empty set. So nothing to worry, just this one, so A, B, C. Because when you take the union, nothing comes because empty set has no elements. What will come? Nothing will come. So directly A, B, C. But in here now we have the element empty set, so they don't have intersection. You just take everything and write in the in here brace, and then okay, this is your answer. Okay, we did some writing also. Very good, very good. Okay, now okay. Also there are some other questions I did. I wrote this before. So you are A, B, C, and universe. A union is clear. 3, 5, 7, 9. Okay. And 2 and 6, because 3 and 5 was already here also. We also add 6. Okay, you are okay, right? B intersect C, are you okay with this? B intersect C, 2, 2, 6, yeah, that's it. C complement. You are looking the universe and then just taking the elements which are in the universe but not in the C. What are they? 3, 5, 7, 9. So 2, 4, 8 we don't want. Okay, 3, 5, 7, 9 we write here. Symmetric difference, you can use this formula. So union we already defined this one. Intersection 3, 5, 7. Now 9, 2, 6 is the answer. You're okay, right? You okay?
Yes, teacher.
Yes, sir.
That's a good news. Now, universal set. What is the complement? Empty set, of course, because these guys have everything. So or means that you can use the other formula like this. So A slash B. Oh, where is A slash B? A slash B. What is A slash B? Where are you guys? 9, yeah. Yes, because 3 here, 3 here, 5 here, 5 here, 7 here, yeah, okay. 9, yeah, of course, because 9 here, but 9 is not here. B slash A, 2 and 6. B slash A, 2 and 6, because 2 and 6 here, but not here. If you make the union, again, you find the same answer. Okay. A union empty, but this empty is an element of a set, so it's here. Okay, so this was one example. My friend, there are some other interesting and maybe challenging examples. This was one example, not exam, it's quiz question. Like, can you see that? In these questions, if you don't understand this, you may not answer every question. So this kind, reading this kind of expressions are important. Right, like, so this is universal set, but it's very easy, right? What are the elements of this? Integers, starting from -2.
-2 to 10.
Yeah, exactly. You are very good. P, what does P says? P says as natural guy. This time natural, and it's from 1, but not 5.
4.
But not 5.
Yes,
Yeah.
From 1 to 4.
what comes? Yeah, exactly. Yeah, and the Q this time, yeah, not 1, but this time
From 2 to 6.
Yeah.
From 0 to 6.
Yeah,
From 2
exactly.
to 6.
Yeah, you are very good. Now, the question was in this quiz, like this A, this P, so P slash Q. Yeah, actually these are written here. So P slash Q. Who will say P slash Q? Edit comments. Do we need to write? I don't know. Okay, let's do with students. So what is P slash Q? Who wants to say?
1.
Sorry.
1.
Can we see question?
1. Okay.
Yeah, 1.
1.
Okay. Let's do together. Union. What about Q slash P?
5 and 6.
Yes, 5 and 6. See, you get, I don't know what point, but you get points from this. Congratulations. And now, yeah, of course, 1, 5, 6. Now, the B part. So as you see, sometimes when they ask questions, they ask in a way that you may use this information also in the next question. So like here, this is the complement of symmetric difference of what? P with Q. So that means universe slash this guy. Now in here, this one is used. This one. Can you see that? So in this kind of questions, these formulas can be useful. Did you understand now? So it depends on what questions you have. So see, if you know that this, you can solve this more easy, this one. But you don't have to know. But if you know that, the student can easily see now, because you know what is this, because we already find here, right? 1, 5, 6. So this part is 1, 5, 6. So that means you are looking the guys, all guys, but not 1, 5, 6. So these ones. From here, you just skip 1, 5, and 6. The rest is the answer. Do you understand now how these formulas can be useful?
Yes.
Yes, sir.
Yes.
Yes, sir.
That's a good news. I am very happy. Okay. We are very happy to understand this. Again, you can find different kind of exercise in the previous exam questions. We have Cartesian products of sets. It's another important subject. If A and B are sets, the Cartesian product or the direct product of A and B is the set. Now, so A cross B. Now, guys, be careful. In the set, you have what kind of? So you have ordered, guys, A and B. Look, A always comes first, and then B. You know, you have parentheses. You don't have braces. So this means in here it's okay. This ordered, guys, but what is the property? So it says that A is from A, B is from B. Okay. So we say A cross B for A, yeah, for this notation. The Cartesian product A Cartesian A donated A square in some places, you know. But then in following this context, so the A to the power n means that you do this cross product operation n times. Of course, then your elements will be like in this parentheses, you have how many elements? You should have components, let's say, n components. So A1, this from here, A2 from here, AN will be coming from this A. The elements of a Cartesian product are called ordered pairs because their order is important. So can you see that AB is not equals to BA unless A is equals to B? So to say that these two ordered pairs equals, first component needs to equal to first component the other one, second component is equals to the second component the other one. Otherwise they are not the same. So this guy cannot be same unless A is equals to B. The elements A and B are the coordinates of the ordered pair AB. Yeah, maybe we can also highlight this. Oh my God. Okay, I will do like that. See, okay. Yeah. So 1 minute. So yeah. So coordinates, and the first coordinate is A and second one is B. The elements of A to the power n are called n-tuples. These are called n-tuples. Here you can also say two couples, but yeah, but better to say ordered pairs. Again, elements of A Cartesian B are equal if and only if they have the same first coordinates and same second coordinates. Can you see that? A1 is so to say that these are equal, A1 is equals to B1 and A2 is equals to B2. Here some exercises for, okay, say that if A is AB and B is XYZ, then A cross B is what? So the best thing is this, the best way is this. So A, X. So you take first A and scan with the other guys, AX, AY, AZ. You finished, right? Now you go with B, BX, BY, BZ. You finished. B cross A, you start with X. Scan all the elements in A, the capital A, XA, XB, YA, YB, then ZA, ZB. You okay with this?
Yes.
Yeah, sure.
And they are different.
Yes, sir.
Yes, of course. A cross B is not equals to B cross A. My friends, in here, as you see in the Cartesian plate, you have this element. So R times R. What does this mean? X, Y ordered pairs. X from R, Y is from R. Here, I will give you this exercise, okay? The same thing we did. Okay, let's look at this example. You have natural numbers. Find the elements of the following sets. Have a look at this example.
Sir, excuse me.
Yes, yes.
For these notes, like the handwriting ones, not the book, where can we find it?
Okay, now look, I will upload this to MS Team. Here.
Okay.
Oh wait, why this is specific person comes? Oh, okay, sorry. Sometimes I have some student send message and it leaves there. Sorry about this. Here, I will do it here. Actually, I will delete this now because I will upload again because I highlighted some other places. So after the class, I will upload the fresh one. Okay?
Okay, sir. Thank you.
Don't worry. Okay. Now let's go back to lesson. So natural, yeah, find the elements of the following set. So look, a guy is this like that. Yeah, in some books they do two dots instead of this like the bar. Do you remember? Like this. Where is this? Like this one. Instead of this bar, in some books they do two dots. So this A is X, guys. This means such that X is a natural number, X is odd, and X squared plus 5 between what? 11 and 31. From here you find, how you find? You use your skills, algebraic skills. So you take 5 to the right and left, okay? And then 6 is smaller than x squared is smaller than 26. Now, you have to be careful. X should be a natural number. X squared can be what? 9, 16, 25. It cannot be 4 because 6 should be smaller than this. Now, you have 3 possibilities. But the guy says X also should be odd number, so we skip this one because if x squared is 16, x you can write 4. Okay? For that reason, x should be 3 and 5. Because from where they come? Because x squared 9 gives you 3. Of course, maybe you can say minus. But minus is not natural number. Do you understand? So for that reason, you take 3 and the 5. Okay? You clear with this?
Yes, sir.
Yes.
Yes.
Yes, sir.
That means these students are very good. Now let's go on. What are we doing? Okay. So x guys are from natural numbers and satisfy this equation. So now, right, x to the power 3 is equals to minus 2. Now, as you see, if you find x, yeah, this is not natural number. Of course, we say just, we are very happy saying that empty. See, empty, nothing. Okay, this is empty. Okay, we have some examples here. So you have universal set, you have A, you have B, you have C. Like it says, like for example, find the complement of what? A intersect B slash C. So you can find A intersect B. The intersect like 3, 7, 8. 3, 7, 8. Isn't it? Yes. Slash C. So 3, 7, 8 slash C. I think 3. Yeah, because 7 and 8 is here. Now, complement of 3 means that you go to universal, just remove the 3. Can you see that? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this means. So that means that when you remove the 3, you ended up with this one, obviously. Okay? You okay?
Yes, sir.
Yes.
Yes.
Yes, I also say yes, and we are very happy to go on with the next one. A symmetric difference B slash B intersect C. My friends, we can use this A slash B union B slash A. A slash B is what? where is A slash B? A. So 2, right? 5, 8. Am I right?
Yes, 2
Yes.
and 5.
It's 2 and 5.
2 and 5. Okay, let's write before forgetting. Not that sometimes oh my god, why this doesn't work? Because my pencil is not here. Okay, so what we said here, do you remember? Who remembers? Or
2 and 5.
2 and 5.
are you sure?
Yes.
I have a bad feeling. Okay, because then from where this 10 is coming? Let me check. 1 minute, please. I believe you, but I have a bad feeling. Okay. Okay. Where are we looking? Oh my God! Wait. I completely lost. What are we doing here? We don't do this, right? Which one we are doing? We are doing this one. Ah, sorry. Okay, 2 and 5. Yes, you are right. You are right. Ah, okay, I understand. But the mistake is with me. Yes, 2 and 5, but 2 and 5 is not this one. 2 and 5 is this one. You know, sometimes this happens to me, so sorry. But you are very good students. You know what I am doing. 2 and 5. Yes. Now, B slash A is what?
9 and 10.
This should be 9 and 10. Yeah, 9 in here, 9 and 10 here, yeah. Okay, yes. Yeah, exactly this one. You have the union 2, 5, 9, 10. Yes. Now, this is 2, 5, 9, 10 slash B intersects C. So B intersects C, 7, 8, 9. Okay? 7, 8, 9, yes. And then you look at the slash. That means the guys in here but not here. Yes, 2, 5, 10. Yeah, you are correct. Okay, you okay with this?
Yes.
Yes.
Yes, hocam.
Yes. Okay, now this B union C complement. So in here you should find what is B union C. I think you can understand this, right? Shall I leave this as an exercise to you? You okay with this? You can find this complement. So B union C is the complement is what? You go to universe, then you get this 1 and 2, right? Are you okay with this?
Yes.
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 Yeah, for this one also you will find this. The important thing is that the order, first we find intersection, then find the complement of this, and then so on. Yeah, here there is one example like A, B, C. Close this guy. So B cross C, I think you know, you take the first element, scan with the others. When it's finished, take 4, scan with the others. Take 6, scan with the other. You know what scanning means? That you are not doing scanning, you know. You're just saying that take 6 and 6, 3. Just 1 minute. B 6, 3. What C? Yeah. 3, 1, 3, 2, 3, 5. 4, 2. Sorry, 4, 1, 4, 2, 4, 5. 6, 1, 6, 2, 6, 5. With BC. You take 3, scan with the C, guys. 3, 1, 3, 2, 3, 5. You take 4, scan with this guy. 4, 1, 4, 2, 4, 5, and so on. I think it's easy. Power sets of B is what? All subsets of B. How many elements? 2 to the power 3, 8. Okay? And then you have B slash A union A slash C. So this is exercise to you. I think today is enough. Isn't it? We saw lots of things. I will upload this fresh one now to the file section. So thanks for today, and hopefully I will manage this video thing. Now, as you see, oh my God, we didn't finish this one. Okay, I see. Anyway, now I will finish this. Maybe this is the reason, because where is the, oh yes, can you see that? Expires in 20 days. Can you see that? My
Yes.
friend, can I
Yes.
ask something? Can you download this to your computer? Does it
Yeah.
allow to you? Can someone try and tell me?
Yes, I can. It says downloading.
Yeah,
Okay.
it's a loading.
Okay.